unlike Wednesday, when I forgot to press that button at the bottom, we are live. This Hangout is on air, and there are people at home in their pajamas watching us right at this moment. Okay, so that's on YouTube. Good. We are live. Right. So, where was I? I was saying that yesterday's class was also pretty hard in our view, but it is always that way in the first tutorial. Getting people logged in has been bigger disasters in the past. Just that first login. But I hope you at least all got logged in and could pass and execute your programs. How did it go in the other classrooms? G and H? Terrible. Say again? Same problem. Yeah, we need to fix the system, but it's really tricky because to change a password, you need a password in, I don't know. I'll talk to them and see if we can change it. Right here. So, oh no, sorry, I didn't want to switch off the lights. I wanted to tell you that before we start, I finally brought along copies of the textbooks, so you just can see what they look like in real physical flesh, so to speak. And since I didn't bring my document camera, and this won't be on YouTube, sorry YouTube, but I can show you what they'll look like. Apparently I can't. Can I press a little button? Oh, okay, I can. I just need to switch over, I think, to this. One is enough. And this. Okay, so we're just looking at the textbook. I just want to once again tell you that this is a textbook. It ought to be in the bookshops, but it may not be. I'm pretty sure there are second-hand copies floating about Salabosh. And this is the new international edition, from which they have conveniently, that's one, see, omitted chapter 4. As you can see. And this is the previous international edition, and it still has its chapter 4. So if you can buy this one, it's chapter 4, it'll actually be a little better. Well, it's better for me. I like physical books, I like physical paper. But you will be able to download chapter 4 entirely legally from the publisher's website. It's just that it's not on paper, which is how I prefer it. But just to show you that these books are absolutely identical. So random section 2.1. It's got a little table at the top, in section 2.1, and I can't show you two pictures, but if we go to section 2.1.2, sorry, all dyslexic. In this book, you'll find exactly the same table on the opposite page, but it's almost a photocopied book. It's not, but it's almost. Okay, so it's really identical. Don't worry if you buy this maroon one instead of this orange one. They really are just about the same. Oakley dokley. Dear YouTube, I'm switching back to the computer screens, which is this button. There we go. There we go. So, one more piece of admin, and that is we need the class representatives. This is important to computer science because we really listen to students' feedback. If you're going too slow, if you're going too fast in our classes, if there's really an issue, we do listen to the students. So we have little meetings of our own once or twice a semester. I think there's one after the first term and another meeting at the end. But there's also the Natural Sciences Students Committee, and they also want to meet. So you have to fill out this little form. It's easy peasy. After class on Wednesday, there were at least one or two people who volunteered. Are they here now? Yes, you are. Anyone else? You. Okay. So I'm going to send you forms. Just fill those in. And can you program? Did you program in school? Okay. You did the bridging course. So the bridging course is covered. Did you do it at school? Bridging course? Okay. Okay. Excellent. So that group is covered. Then someone sent me an email to nominate someone else. Okay. But honestly, don't be shy. Are you here? I can't remember. I can look up your name, but it's too lazy to do that. Is the person who was nominated here? Let's stick around because we're not here. We're not a very good class. So everyone has to speak in class. So now we still need the representative or someone who has programmed at school. Excellent. And I can do with many. I've got 5 forms. 6 actually. Isn't that before like that's the doesn't matter. Reaches someone who wants it. Alright. Okay. So that's 4, and I guess it's kind of enough. But I do want to find a representative from someone who can sit under there. Right. So that is one. Okay. 5 is the perfect number. Just fill out those forms. Read the declaration because you may not like it. I mean, I kind of try to downplay this, but it says, I declare I'm willing to accept the responsibilities. I will attend meetings, as informed via email, SMS, or phone call, unless a legitimate excuse. Oh, you can always say you're going on a hockey tour. Can't you, Miss LaFleur? I'm going to hockey my brains out. Okay. I will attend meetings unless an excuse. I will provide all information as correctly as possible. You only need to write your signature. Okay. And what else? I will treat my fellow students and lecturers with respect and dignity. Okay, right. Okay. So now on Wednesday, when I was so late, we didn't really do what we had to do. We didn't cover my first program, which was what the TAT was essentially about. So I'm quickly going to go through those slides, but it is also in the book. Everything I do is in the book, although I don't often refer to the book. This course is based entirely on this book. When I design a schedule, I just go through the book and see, okay, we've got to cover all these materials. So I just parcel it up into the separate weeks. And you can check from the reading, we're going to cover all of the pages, at least in the first 2 chapters. So you could also read pages 4 to 9 for today, could have. But definitely for Monday, try reading pages 14 to 24. Especially if you haven't programmed before, it'll help if you don't have to study it, just read it casually while you're lying in a hammock, sipping on a martini or whatever. And when you go to class and I repeat it, when you go to TAP, repeat it again, that's the way to learn, just repetition. These slides I'm going to take away. I honestly just haven't had time. I almost haven't had sleep, but I'll put up yesterday's tutorial slides later today after my other courses are finished, and I'll put on the slides I do today as well. So let's just, I'm not going to go too fast, but let's just work through these slides. So that little button and, okay. So I told you about this lady, and I actually wanted to bring along some of her quotations because it's hilarious. She honestly thinks she's the greatest mathematician that has ever lived. And she complains about the other imbeciles around her who can't see that fact. Meanwhile, she didn't do much. Even on the machine, on this Babbage's programming machine that he made, she almost, you could say she just copied his reports and didn't contribute too much of herself at all. Having said that, she was very famous. She was Lord Byron's daughter. So she did do some promotion for the difference engine and the analytical engine. The rest of the slide is saying that if we had the perfect computer, we could just ask it to do things for us, like Siri, but more powerful. We could say, I want to write a program to do X, Y, Z, and the computer will just listen to your English instruction and do it. But firstly, English is ambiguous, so whenever we specify a program, it's difficult for a computer or even other people to tell exactly what we want. We may not be accurate enough in our language to say what we want clearly enough. And secondly, we've tried this We've been trying this for a long time. It's a research area called automatic programming, and in fact, in the 1980s, the Japanese government put millions and millions of yen into this, and it still hasn't panned out. So it may not be possible. If you can find a software package that does exactly what you want, that's fine. But sometimes, most often, it doesn't exist. Or it doesn't exist to do, something doesn't exist that does exactly what you want. So you have to write it, yourselves. And that's really good news for us, because it means that in the future there will be jobs for us to develop new software. You'd think that after 100 years, let's say, all possible programs that could have been written have been written. But that's simply not the way it goes, and the technology change. 30 years ago, we didn't have email, but now all applications need to incorporate email in some way for some reason. So there's a need for programmers, there's a need for software developers, and that's what we are training to be. Oakley Doakley. So, famous computer science scientist Donald Knuth. When we write programs, we're not writing for the computer. The computer wants Java, it wants zeros and ones. But we don't want to write zeros and ones. We ourselves want to be able to read what we write. So we use a high-level programming language. And we also write for other people. You show it to your colleagues at your new job. You earn millions in Silicon Valley. And they need to be able to understand your Java code. So it's not only about writing programs at work, it's also writing programs that people can read and understand. So it's as much like an essay that you're writing to the people you work with as it is instructions for the computer. Why don't we use English? There are all these famous headlines that are actual headlines. Kids make nutritious snacks. Oh, delicious. Red tape holds up new bridge. Local high school dropouts cut in half. Oh my God. Okay. My favorites are things like when you rang the doorbell, she came down in her nightie and opened it for him. Or when the plane crashed, the pilots, the fuselage trapped the pilot's head. This had to be removed before he could be freed. So things like that is ambiguous. The way I said it, they didn't remove the fuselage, they removed his head before he could be freed. So imagine what a computer does with that. How does it parse that? So trade-off is that we are going to use not English, not some zeros and ones, but something that's called a high-level programming language. Hi guys, don't worry, it's fine to see it. Cover it up. It's fine. Otherwise, it's fall. We're going to use a high-level programming language. It's called high-level. We'll see about that. We're going to use Java. That's the guy who basically made Java. It is widely used. It's amazing how popular Java has become in a very short time. It's widely available. So if you write the program and you make your .class file, you'll run that exact same .class file will run on a Windows machine and on a Mac and on a Linux machine and on a phone and even maybe a Nokia phone, really old phones, and it will run on devices like tumble dryers and all kinds of stuff. Obviously, if they have a virtual machine. That's not true for other languages. If you write a program in C and you compile it and you get the equivalent of a .class file, that file only runs on the machine where you compiled it. You can have an identical machine next to it that has just slightly different libraries installed, and your C file won't run at all. Your C class file. So the whole idea of Java was to be portable. I mean, that was the original idea, that you can write it once and distribute it everywhere on the web. It was also made for small devices like tumble dryers or writing code to control an electronic door or all kinds of embedded devices. And then it says Java economy. Yes, so there's a lot of stuff, a lot of devices that run Java, that's based on Java, and it represents millions of dollars. There's really millions of dollars in this economy. In fact, in the whole software economy, there are millions of dollars. Modern economies are driven by software. If all the software disappears, the global economy will collapse. And that's also true for other things. If global shipping If all ships were to disappear, global economies would collapse. But not as fast as the collapse of the software code. It's a little scary that computers are so unreliable and so difficult to use, but we rely on them to such an extent. 5 million developers is probably, I don't know, accurate-ish. Not sure about that, because that's an awful lot of people. I mean, that's the entire population, almost the entire population of Sweden. And who knows? Who knows these things? I don't know. Okay, here's another guy who made a different language called C++. If you can, please avoid C++ for the rest of your life. It's a horrible language. It's based on C, which was an okay language. Little tricky, but powerful enough to be really useful. C++ is really complicated. It's about 3 times the size of Java. The semantics, how it works, is much more difficult to understand. Having said that, you'll probably be expected to learn C++ in a couple of weeks once you've know how to program. But in any case, this guy made it. He's Danish. His name is Janus Trustrup. As Danish people say their names. No, that's really how he says it. There are only 2 kinds of programming languages. Those people always write about, and those nobody uses. So what he's saying is that either the language is dead and nobody uses it, or if it is being used, there will be a lot of people griping about it. You'll start griping about Java. Why does it work this way? Why can't do this and this and this? Why doesn't it have such an extension? But everybody, all languages have people who gripe about them, and that's just the way it is. So the bottom line is chill out, relax, just accept Java for what it wants to be. It's a nice language, but it's not perfect. There is no perfect language. And we use the right tool for the right job. Sometimes it's Java, sometimes it's C++. Oh, okay, right. Blah, blah. Right. So this slide contains a list of all the keywords and little squiggly marks we'll learn in this course. Basically, if we've covered all of them, you understand how to use them, you'll know Java. So I got these slides from the people who made this textbook, and I adjusted the slides some, but I kept most of the slides. I don't really like this slide because I don't know what the purpose is. Are you supposed to come back to this slide 6 months' time and say, okay, tick, 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 I know all this. I know how to use the brace, click, I know how to use the parentheses. But perhaps it's to tell you that don't be scared, it's not that big. If you were forced to, you could probably memorize this in one day. Not know how it works, but you could probably at least memorize all the words. It's not that much. Having said that, with these limited keywords, we're going to do really fantastic things. We're going to write games and stuff. So, you ought to know from yesterday that there are 3 steps when you write programs. We create the program, we write the code in an editor, then we compile it to make it a class file, and then we execute the class file on the computer. And at that stage, we'll probably find that either we've made a mistake, it doesn't even compile, so we may not get to this step. We may be stuck at compiling because we've made some kind of syntax error, and we have to go back and change our program a little, try to compile again. Or it may be that even though it compiles and executes, there is still a mistake in the program. It's a runtime error. So the errors that happen when we compile are called compile time errors. So if you make a mistake in the syntax of your program, that's a compile time error. If your program's perfectly correct in the sense that it compiles, it may still not execute the way you want it. You may want to write a program that adds 2 numbers, but instead it's subtracting or multiplying. That's not what you want, so that's called a runtime error. What? Yes. So these slides are to tell you a little more about the steps. So create. We use an editor. Just type it as if we're typing a document in Microsoft Word. Editors for programs usually have different features, not word processing features, because we're not writing documents for people, although I did say programs are for people, they are. But the features we need are a little different. So for example, most editors will highlight keywords in Java. And the only choices you have to choosing I'll get back to that sentence, just hold it. Put it on the stack. Right, so this is the program, the kind of programs we are going to write. They're all going to look like this. They're all going to have this public class, and then the name of the program. In this case, I've called my program Hello World, and that's the choice I've made. But this public and class are fixed. They must always be there. And I must always put a brace. And the first few times, if you've never programmed before, you're going to forget about this brace. Or you may forget this closing brace at the end. And then inside public class and my little program, we always write public, static, void, and then this also stays the same. Main, strings, string, bracket, bracket, args, close parentheses, open brace, and the closing brace at the end. For now, for the first couple of weeks, all we are going to change is what's inside this inner brace. So the only thing we are going to change is when it says system out, print line, and the world. That'll be our area of change. What you didn't see yesterday is that actually anywhere in the program you want, not in the middle of the word, but anywhere between words or punctuation marks, you are allowed to put comments. This is part of the program that the compiler will ignore. So it's not going to translate this comment at the top to the .class file. The purpose of this comment is only to explain how your program works to other people or to yourself who are going to read this program. So to write a comment, you start with the slash and the star. Only the first slash and the first star is really the start of the comment. I did put a lot of stars, but I really didn't need them. The first slash and the first star is what tells Java a comment is coming. And I really only put the stars there because it looks neat. In fact, I always do this, and in fact, most programmers do this. You want to kind of delineate your program, so a row of stars is actually quite effective way of doing that. And inside, I can put anything I want. You can put a little ASCII drawing, or you can put a poem, or sensibly some kind of English explanation of what this program does. Or you can put a program here inside the program, what the next step of the program is, what it's all about, what it's doing. So in here, you can write anything you want. Once again, these stars, oh no, it's not going to try to, no, it's not going to the next slide. These stars at the start of these two lines, they're not necessary either. I just put them there because it makes a little box. And the stars here at the end are not necessary either. They're all just for decoration. The only ones that count is this very last star, the very last slash. This tells Java that it's the end of the comment. And the rest of the program itself, the main program, is now actually continuing from here. So Java will, the compiler, will take everything from the first slash and the first star up to this last star and the slash, forward slash, and throw it away. It won't go into the class file. It's not translated to instructions. It's not important to the compiler what I put in there. This is for humans, for explanation. Right here. So we use an editor. We write out the program. We put in it what we want the computer to do, and we have to call it whatever name we chose for the program over here. I chose to call this program Hello World. We have to call our file. We save this program in hello world.java. That's an absolute rule. There's nothing else we can do. If we don't do this, Java will complain. And it makes sense. If you're calling your program hello world, you put in the file called hello world.java. Okay. Hopefully you won't complain about that. When I copied this over for the tutorial, I of course left the hello world, but I wanted to call the program greet.java. So the compiler would have complained if you tried to do that. In yesterday's stat, this should have been greet. But a good lesson to learn. By the way, this program is called Hello World. Almost every single person on this planet who learns the program starts by writing the Hello World program. It's just like a tradition. It's the first thing you want to do. I'm not sure what it's called in other languages. I don't know if the Germans teach their students to write Guten Tag, Welt, or the French say Bonjour, Le Mans, or whatever the French say. I mean, these crazy people. But in the English-speaking world, hello world. Okay, so this is your first milestone. In fact, you've already passed it, I hope, because you got this up yesterday. Oakley dokley. Now, we've written our program in the editor, we save the file, now we need to compile it. I hope you saw this yesterday. We use this command, the shell command called javac, and the file name. So this is not the name of our program, it's the name of the file. And it so happens that Java forces us to use the same name for the file and the program, but that's just a coincidence. Other languages don't. So I'm saying javac, this is my file name, we'll find the program in this file, and the Java compiler will open the file, read it, look at the instructions, throw away the comments, and translate it to a .class file. We're using the command line, using the shell, runs in the terminal, for the first half of this course, because that's something you must learn. If I come across someone who claims to be a computer scientist and they say, I don't know the command line, you know what I do? I just shut my car window and say, I don't want the burger. I'll just go see it. Kentucky. Because that's where those people are probably working. Right? I don't know how we got onto the topic of whether they know the command line or not, but real computer scientists know the command line. Even if you use fancy IE, that is not going to impress anybody. Okay? The command line, under the hood, that's the kind of knowledge you need. You'll find out. Next year you'll find out what goes on under the hood. You'll find out what goes on in the operating system. So on these slides, I sometimes use a percentage sign to indicate the prompt of the shell, and that's because some shells show a percentage, but often it's a dollar sign. Doesn't really matter. It's just to show you that I'm typing at the command line. So I type javac hello world Java at the command line. The compiler starts up, it translates my program, it creates a .class file. And the third step, if there weren't any compiler mistakes, compile errors, is to run my program. So I'm using a different command. This time I'm using the Java virtual machine. I was a little tired yesterday, and after the stress of how difficult it was to log people in, I was a little weak. I didn't even go to the RW page. I just assumed that whatever chaos was happening there would be contained and I wouldn't know about it. So I just went home. And I don't know what happens in those classrooms. I haven't spoken to the assistants yet. But in our classroom, in the big NACD, at least for half of you, I showed you VirtualBox as a way of installing Ubuntu on your Windows machine easily, or installing a second Ubuntu on your Ubuntu machine. You can have VirtualBox in Ubuntu and have an almost recursive virtual machine. But that VirtualBox creates a virtual machine on which you can install Ubuntu. And this Java command actually does something a little similar. It runs what is called a Java virtual machine. It's definitely not as powerful as VirtualBox, but it is almost, well, very much the same kind of thing. So this starts a little machine that can execute Java programs. And in this case, we say, start the virtual machine, and this is the name of my program. It's not a file name, it's the name of my program. And Java is clever enough to know that this is the program name. The file with the instructions will be hello world.class, and it will go pick up the class, the class file. It will load it up, and it will execute whatever instructions the compiler generated. And in this case, it will print hello world. Let's just go back one slide. I wanted just to make two slides clear. So Just as in the bridging course, if you're taking the bridging course, you may remember that I said you only need to learn about 5 instructions for the computer to learn how to program anything you want. You must be careful because I love to lie to students. It's my hobby, one of my big hobbies. And even when I'm not lying, I'm being sincere, I may not be accurate. So you should not believe anything I say. You should double check every single thing. But you must trust me sometimes. So this time I'm being entirely sincere when I tell you that if you know 5 Java instructions, you can write any program on earth. There is a technical name for this. You won't get it in this course called Turing completeness. With 5 instructions, you can write absolutely any program. And in this course, we'll be learning those instructions one by one. And the very first one we need to learn is system.out.println. This is an instruction that tells Java, tells the computer, I want to display something on the screen. I want you to print something on what's called the out stream. So we get this instruction, and in parentheses we put the string in quotation marks, double quotation marks. The string we want to appear on the screen. In this case, we want hello, world to show up. That's a string. We're passing it to this instruction, and at the end, you put a semicolon. You must put the semicolon if you don't bother or complain. Java is very strict about its syntax, as all languages, because the computers are stupid. They can't tell what you really want to do. You have to kind of explain it to them. The same is true for your colleagues at your new job. They're pretty stupid, and you have to explain to them explicitly what you want to do. But that's not a bad thing. You are using some protocols. You're using the Java language, which everybody agrees on. So that makes things clearer. But you have to stick to the rules. So a semicolon at the end of print line statements. When we execute this program, the one single instruction is print hello world on the screen. When we execute it here, start virtual machine to execute hello world, and it does as we instructed it. Hello, world appears on the screen. Oakley dokley. Just for interest's sake, this is what is put in the class file. This is the contents of the class file. Clearly, you can't look at this too long. It causes headaches, nausea, dizziness. Nobody looks at this, I promise you. Nobody looks at this next time. But it's interesting to know what's going on here. I mean, we can recognize some parts of it. I mean, let's see. Here it says init, don't know that. Code, well, who knows. Line number table, interesting. Main, we did write the string main in the file. Java, lang, string, sounds familiar. Source file. Hello world. Oh, okay. So here it says hello world. I'm trying to highlight this, but it won't work. Okay. No, hello world.java. Oh, that's just the file name. Hello, world. Oh, there we go. Oh, there's another hello world. Okay. There's lots of stuff. I don't really understand what's going on here. All these little bits and blocks, they're instructions that the computer will understand. We don't need to bother about this. We're not going to code like this. Imagine if this was a course in low-level programming languages, and you had to write this to display hello world on the screen. We'd have 5 people in class. And one of them would be the bodyguard, and the other would be really only 3. You must take off your glasses if you can't see. You can see. By the way, this is called Java bytecode. Bytecode is what Java secret word for instructions. It's another name for instructions that the compiler puts in the class file. You don't need to worry about it, but you'll hear it often. Okay, so that's what we should have done on Wednesday. And I'm too lazy to start the next chapter. So and it's needed in any case. But what this means is that in this very first week, we've had one power cut, one really late class, disaster start, and now we are 1 week behind on the schedule. So within the first week, I managed. That's great. But I'm so chilled about this because it's not important. Even if we fall behind 4 weeks, it doesn't matter. As long as we learn something. I pride myself on teaching my students 1, 2 things like most during the course. So that's all I'm aiming for. Don't pack your stuff away, we're not done. We still have 2 important things to talk about. Firstly, the representative. You'll bring your forms to here. That'll just be easiest. Bring your forms after class. And the second thing is, I want to thank you for coming to our April class. I know it's not all of you, but I can't make promises about the future. I know I'm not supposed to do that. But just to encourage people to come to this class, I'll bring along some chocolates next week and distribute them to enthusiastic students who can clearly recognize my own greatness. And what's more is, maybe I should play you a little video. I love playing little videos, but no cats. You want a cat? Okay, I was going to play the chat roulette video because I love that. Every morning when I wake up, I play that video to myself, but all the bridging course people have seen it. So let's just play a cat video. Hang on. Okay, great. Oh, no. See, that's it's very finicky getting the sound right. Getting the sound right in these classrooms, so this laptop is still not operating. But luckily, the cat video has no sound, so I'll play that. I'll play it. Okay, now just hang on. Before I play this video, I just want to assure you that I love cats. Okay? I've got cats of my own, and no cat was hurt intentionally during this video. So don't get upset, people, please. I don't want like many emails about how I hate cats and I'm going to die. Those cat people are vicious. No, why would I want to? Oh, it is playing. Ignore it. Oh, good sound. Good. No, it's not. It's a little dance. Little cat dance. Look at the guy. It's good move. Oh, God. Oh, that was too bad. To have. Okay, I don't have a different cat video. I'm so sorry. I'll just play you one small little video so you can wake up and have a little laugh, and then we'll go home. Well, I won't go home. You won't either, but then we'll be. Okay. So I'll see you on Monday.